beta ECG, what is the it is the hormone we can measure in case of pregnancy confirmations. আর কোথায় লাগে? ওই তো না বিটা ECG. Beta ECG important কেন? Why beta ECG important? Because it is after it is secreted from syncytiotrophoblasts and it is appear in the female urine approximately 7 to 10 days after conceptions, and it is now their concentration has steadily rise up to 10 to 12 weeks, and after that 10 to 12 weeks their concentration are falling. Why their concentration are rising and then falling? Because the main two hormone that is responsible for the for the maintenance of the fetus, that is the estrogen and progesterone. And estrogen, where estrogen are synthesized synthesis from DHEA, dihydroandrostenedione, and dihydroandrostenedione, it is converted to estrogen by fetal adrenal cortex, and fetal adrenal cortex won't develop up in between 0 to 10 to 12 weeks. So estrogen lack of estrogen. In case of progesterone it is synthesized from the mainly, except the corpus luteum, it is synthesized, but the progesterone main source is the placenta, and the placental mass মানে the weight, it is proportional to the তোর secretion of progesterone. তাহলে প্রথম 10 to 12 উইকসে কি হবে, তোর প্লাসেন্টা ডেভেলপ করবে না ঠিকঠাক টাইপ, তাহলে প্রজেস্টেরন ঠিকঠাক পারবে না। সো এই যে সময়টা মাঝে যে 0 to 10 উইকস অর 12 উইকস, এইখানে যে ফিটালসের যে ওয়েলবিং, ম্যাচুরেশন, মেনটেনেন্স, all are responsible for the due to the beta ECG. তো বুঝতে পারছি বিটা ECG কতটা ইম্পর্টেন্ট। ওকে, সো এগুলো হচ্ছে তোদের নতুন যে কারিকুলাম যেটা যোগ হয়েছে সেখানে আছে, ঠিক আছে। কারণ পরীক্ষায় প্রশ্ন আসতেই পারে যে ফিজিওলজিক্যাল এফেক্ট অফ সেক্স হরমোন, তাহলে তোকে কী করতে হবে, মেল আর ফিমেলে ভাগ করাতে হবে। তাহলে মেল তো আমি পড়িয়ে দিয়েছি, জাস্ট আর তো রিক্যাপিচুলেট। মেলে হচ্ছে দ্যাট ইজ দ্য টু হরমোন, টেস্টোস্টেরন আর ডাইহাইড্রোটেস্টোস্টেরন, ঠিক আছে। ডাইহাইড্রোটেস্টোস্টেরনের কাজ কি বলেছিলাম, ফর দ্য সেকেন্ডারি সেক্সুয়াল ক্যারেক্টার অফ মেল। টেস্টোস্টেরনের কাজ কি বলেছিলাম, প্রাইমারি সেক্সুয়াল ক্যারেক্টার, লাইক এনলার্জমেন্ট অফ দ্য পেনিস, all that the primary organs, that is the responsible for the testosterone, and dihydrotestosterone for the secondary sexual characters. তাহলে কি করতে হবে তোকে, তাহলে লিখতে হবে মেলে দিয়ে লিখতে হবে যে there is the two hormone। ডায়োটেস্টোস্টেরনের কাজ লিখলি, টেস্টোস্টেরনের কাজ তোরা জানিস কি কি কাজ আছে, একটা হচ্ছে মেটাবলিক এফেক্ট, সোডিয়াম পটাশিয়াম রিটেনশন, ইনক্রিজ দ্য প্রোটিন অ্যানাবলিক এফেক্ট, তার ফলে কি হয়, মেলে মাসেল মাস বেশি হয়, মেল সাইকি, মেল প্যাটার্ন, তারপরে কি আছে আর আছে তোর ইট হেল্প ইন এরিথ্রোপোয়েসিস, যেগুলো তোকে পড়িয়েছিলাম টেস্টোস্টেরনের কাজগুলো। তাহলে এফেক্ট মানে হচ্ছে তোর ওগুলি লিখতে হবে, বুঝে গেল। তারপর ডায়োটেস্টোস্টেরনের কাজ লিখলি, আর ইনহিবিনের কাজ তো পড়িয়েছিলাম, ইনহিবিন, টু টাইপস অফ ইনহিবিন, ইনহিবিন এ অ্যান্ড ইনহিবিন বি। ইনহিবিন বি ইজ রেসপন্সিবল ফর দ্য তোর ইনহিবিশন অফ FSH। তো FSH হরমোনকে তোর ইনহিবিট করছে। তো এটা মোটামুটি তোর যদি 5-5-10 নম্বর প্রশ্ন থাকে, তাহলে 5 নম্বর মেল লিখতে হবে, 5 নম্বর ফিমেল লিখতে হবে, যেহেতু ইকুয়াল কন্ট্রিবিউশন। এবারে বাকি পড়ে রইল 5 নম্বর। এই বাকি 5 নম্বরের মধ্যে এখন যদি ইস্ট্রোজেন, প্রোজেস্টেরন, বিটা ECG, এলএইচ এফএসএইচ আলাদা করে লিখতে যাস তাহলে মোটামুটি বাকি আর তুই কোনো প্রশ্নই শেষ করতে পারবি না। তো ইন শর্ট লিখতে হবে, ঠিক আছে। তো ইন শর্ট লিখতে গেলে কি করতে হবে না, মেনলি এফএসএইচ আর এলএইচ কোথায় লাগে? ইন দ্য মেনস্ট্রুয়াল সার্কেল। আর তো কোথাও লাগে না, মেন মেনস্ট্রুয়াল। তাহলে কি করতে হবে, ওইখান থেকে কিছুটা মেনস্ট্রুয়াল সার্কেলে ঢুকে কিছুটা লিখতে হবে যে এফএসএইচ আর এলএইচ এর কাজ কি আছে। হ্যাঁ, একটা আমি চার্ট বানিয়ে নিয়েছি তোদের। দিস ইজ দ্য অ্যাকশন অফ এফএসএইচ অ্যান্ড এলএইচ, ঠিক আছে। সো এফএসএইচ এলএইচ এর প্রথম প্রিকারসারকে গোনাডোট্রপিন রিলিজিং হরমোন জিএনআরএইচ ফ্রম হাইপোথ্যালামাস এন্টার করছে কোথায়, ইন দ্য পিটুইটারি বাই এফএসএইচ অ্যান্ড এলএইচ। জিএনআরএইচ কি হচ্ছে, ইন আ পালসেটাইল ওয়ে। হোয়াই পালসেটাইল? পরীক্ষা প্রথম জিজ্ঞেস করতে পারে এক্সামিনার, বিকজ it prevent the down regulation of the receptor. That's why it is the pulsatile in nature. Okay. Now FSH or LH. FSH হচ্ছে কি হচ্ছে না, you know the FSH is and estrogen are secreted first and LH last. And why FSH first? Because the FSH is sensitive for the small amount of GnRH. তো যখন GnRH অল্প সিক্রেশন হচ্ছে, that stimulate the FSH much better. Exception হচ্ছে LH. LH কি হচ্ছে, it is sensitive for the higher concentration of GnRH. So that's why first the FSH are secreted, ঠিক আছে। And FSH are responsible for the production of estrogen. তাহলে প্রথম ফেজে কি হচ্ছে, প্রথম ফেজে আর্লি ফেজে ইন দ্য মেনস্ট্রুয়াল সাইকেলে, তো এগুলো কিন্তু সব পড়ানো হয়ে গেছে, মানে এটা আমি তোদের জাস্ট রিক্যাপিচুলেট করছি, কিন্তু সবই পড়িয়েছিল। তো এফএসএইচ আর ইস্ট্রোজেন প্রথম দিকে বাড়ছে, ঠিক আছে। অ্যান্ড হোয়েন দ্য জিএনএইচ সিক্রেশন আর আপ অ্যান্ড হায়ার কনসেন্ট্রেশন, নাও এলএইচ আর now the main dominant factors. So প্রথম দিকে এফএসএইচ কি করছে, প্রথম দিকে এফএসএইচ কি করছে, না ওভারিতে অ্যাক্ট করছে। ওভারিতে অ্যাক্ট করে কি করছে, ইট হেল্প দ্য গ্রোথ অফ প্রাইমারি অ্যান্ড সেকেন্ডারি ফলিকলস। ওকে। অ্যান্ড প্রাইমারি সেকেন্ডারি ফলিকলসে অ্যাক্ট করে কি করছে, ম্যাচুরেশন অফ ওয়ান ডোমিনেন্ট ফলিকলস। তো জানিস যে এফএসএইচ কি করে, দেয়ার ইজ এ so many follicle in ovary, but ultimately one follicle is developed, that is called the dominant follicle. Why one follicle is developed? Because these follicles are sensitive to FSH and only one follicle have a highest concentration of FSH receptor of their surface. As their FSH concentration goes down, so definitely one follicle are survive and other will die eventually, because they have a higher concentration of FSH receptors. That is why called the dominant follicle. এটাও কিন্তু পরীক্ষা শর্ট নোট জিজ্ঞাসা, মানে তো ভাইবা জিজ্ঞাসা করে, why that is called dominant follicle. ওকে। সো একটা ডোমিনেন্ট ফলিকল ডেভেলপ করলো, দ্যাট কি করলো, ইনক্রিজ সিক্রেশন অফ ইস্ট্রোজেন অ্যান্ড ইনহিবিন বাই গ্রানুলোসা সেল, ঠিক আছে। সেখানে অ্যাড করলো কোথায়, ইন দ্য ইউটেরাস টু রিপেয়ার অ্যান্ড পলিফারেশন অফ এন্ডোমেট্রিয়াম। ইস্ট্রোজেনের কাজ, এগুলো ইস্ট্রোজেনের পরে আমি পড়াচ্ছি। এটা হচ্ছে তোর ইন শর্ট অফ এফএসএইচ। এবারে এফএসএইচ এর কাজ যদি একটা মেনস্ট্রুয়াল সার্কেল লিখতে যাস, তো পরীক্ষার সময় তুই তো কমপ্লিট করতে পারবি না, কারণ সম্ভব না একটা গোটা মেনস্ট্রুয়াল সার্কেল লেখা। তো তোকে এফএসএইচ এর ওই অল্প করে বলে দিতে হবে, দ্যাট ইজ দ্য অ্যাকশন অফ এফএসএইচ। ওকে। নাও কাম টু দ্য এলএইচ। এলএইচ কি করে, ফর্মেশন অফ কর্পাস লুটিয়াম। কর্পাস লুটিয়ামের কি কাজ করে, ইনক্রিজ সিক্রেশন অফ প্রোজেস্টেরন। তোকে বললাম যে এফএসএইচ সিক্রেশন করে ইস্ট্রোজেন আর এলএইচ সিক্রেশন করে প্রোজেস্টেরন। ওকে। সো increase secretion of progesterone and estrogen by the cells of corpus luteum আর কি করে ইনক্রিজ সিক্রেশন অফ ইনেভিন বাই সেল অফ কর্পাস লুটিয়াম। সে দুজন কি করে আলটিমেটলি কি করছে না প্রিপারেশন অফ এন্ডোমেট্রিয়াল ফর অ্যারাইভাল অফ ফার্টিলাইজড ওভাম, ফার্টিলাইজড ওভামের জন্য তোর ইউটেরাসকে প্রিপেয়ার করে। ওকে, so this is the action of FSH and LH. You know what is corpus albicans? মেনস্ট্রুয়েশনে পড়ানো হয়েছিল, পড়ানো হয়নি মেনস্ট্রুয়েশন সময়? মেনস্ট্রুয়াল সাইকেল পড়ানো হয়েছিল তো? মেনস্ট্রুয়াল সাইকেল তোরা পড়িয়েছে, ওভারিয়ান সাইকেল পড়িয়েছে। ওকে, সো তোদের কিন্তু পরীক্ষায় ওইভাবে মানে আমি চেয়েছিলাম যে ফিমেল রিপ্রোডাক্টিভ সিস্টেমটা যেমন মেল পড়িয়েছিলাম পড়াতে, কিন্তু তোদের নতুন যে সিলেবাস হয়েছে সিলেবাসে ওইভাবে দেওয়া নেই, ঠিক আছে? সো নাও হোয়াট ইজ দ্য কর্পাস অ্যালবিকান্স? কর্পাস অ্যালবিকান্স মানে হচ্ছে তোর এই যে ডমিনেন্ট ফলিকলটা দে বিকাম দ্য ফলিকল হুইচ আর টু বি ফার্টিলাইজড, ঠিক আছে? এখন ওই যে ডমিনেন্ট ফলিকলটা ফার্টিলাইজ হলো না, তাহলে কি করবে? দে ফর্মেশন অফ আ হোয়াইট স্কার ইন দ্য ওয়াল অফ দ্য ইউটেরাস, and this scar called the corpus albicans. বুঝা গেল? সো কর্পাস অ্যালবিকান্স মানে হচ্ছে এটা ফার্টিলাইজ হলো না। এই দুটো তোর ফার্টিলাইজের জন্যই FSH LH অল ফর ফার্টিলাইজ। নাও এই পার্টটা হয়তো ফার্টিলাইজ হলো না, তার ফলে কি হবে? দ্য নো সিক্রেশন অফ প্রোজেস্টেরন অ্যান্ড ইস্ট্রোজেন বাই কর্পাস অ্যালবিকান্স। কর্পাস অ্যালবিকান্স মানে সেটা তোর এই কর্পাস লুটিয়াম, হ্যাঁ, এগুলো তো তৈরি হলো না। তার মানে কি? তার মানে দে আর নট ফার্টিলাইজড। এবার কর্পাস লুটিয়াম তৈরি না হলে ইস্ট্রোজেন প্রোজেস্টেরন তৈরি হবে না, বিকজ অল আর সিক্রেট ফ্রম কর্পাস লুটিয়াম। তাহলে কি হচ্ছে? নো সিক্রেশন অফ প্রোজেস্টেরন অ্যান্ড ইস্ট্রোজেন বাই দ্য কর্পাস অ্যালবিকান্স। তাহলে কি হলো? দেয়ার ইজ এ শেডিং অফ এন্ডোমেট্রিয়াম অ্যান্ড দ্য মেনস্ট্রুয়েশন অকার্স। সো দিস ইজ ইন শর্ট দ্য action of FSH, LH, and if FSH, LH not occur, how it happen. পরীক্ষার সময় তোদের কিন্তু ওই গোটা মেনস্ট্রুয়াল সাইকেল লিখতে গেলে ওটা তোর মানে আর বাকি কিছু লিখতে পারবি না, তোকে মোটামুটি এইটা অল্প করে লিখে এলে মেনস্ট্রুয়াল সাইকেলটাও কভার হবে প্লাস নাম্বারটাও পাওয়া যাবে। তো আমি খুঁজে মানে এই মনে হলো যে এই স্লাইডটা হয়তো তোদের পক্ষে মানে ঠিকঠাক হবে, আমি তাই নিয়ে এলাম। নাও তাহলে FSH LH হয়ে গেল, এবার রয়ে গেল তোর ইস্ট্রোজেন অ্যান্ড প্রোজেস্টেরন। হোয়াট ইজ ইন মেল পার্ট টেস্টোস্টেরন দ্যাট করসপন্ডেড উইথ দ্য ফিমেল পার্ট অফ ইস্ট্রোজেন। তাহলে কি হচ্ছে? তাহলে in male it is responsible for the male psyche, and what is the action of estrogen? Estrogen is responsible for the female psyche, ঠিক আছে? So all our female psychological character are developed due to the estrogen. আর কি করে? It responsible for the development or the developmental growth your adolescence period. 3 typical body characters of female. What is the typical body character? Short shoulder, wide hip. There is a convergence of your thigh, and there is a wide carrying angle. All are the typical female characters, except there is a excess depositions of fat in the breast and buttock. There is a child type of high pitch voice. This is all the typical characteristics of female that is developed by the estrogen. So in brain it helps to maintain the body temperature and accept all I said in the brain. Now come to the breast. Progesterone responsible for the development of breast in the adolescent period as well as in the childbearing period. In the adolescent period, it helps to proliferation of ductules, breast alveoli, and the ductules all are proliferates, and there is a deposition of fat in the breast. So there is a increase enlargement of breast in the puberty, and female during childbearing periods, it also help to increase amount of ductules, and there is a so responsible for the lactating periods. Okay? So that is the important. Now the ovary, it estrogen stimulate the ovarian functions and ovarian so enlargement and ovarian secretion of certain hormones. Okay. Bones, what about bones? Bones তুই জানিস যে why there is a two type of cell in our bones. One is the osteoblast and osteoclast. Osteoblast responsible for the bone formation and osteoclast are responsible for the bone dilution. In perimenstrual period, যখন menstrual period চলছে, estrogen help the osteoblastic activity. So it help the bone formations, and post-menopausal women, there is a chance of osteoporosis is greater. Why? Because absence of estrogen, now the osteoclast take the upper hand. এতদিন ছিল osteoblast, এখন মেনোপজ হয়ে গেছে, estrogen secretion কমে গেছে, এখন osteoclast take the upper hand. তাহলে কি হবে? বোন ডাইলিউশন হবে। তো বোন ডাইলিউশন হলে কি হবে? বোনের ক্ষয় হবে। That's why in Indian scenario, in postmenopausal women where the dietary calcium are low in our food, postmenopausal osteoporosis is much more common in female. বোঝা গেল? Now in the vagina, estrogen কি করে না help and maintenance of vagina, also the growth of vagina, and also it secreted some very thin lubricant, and it is responsible for the fan-like pattern in the vagina. So that is the action of estrogen in the vagina. ঠিক আছে? ইউটেরাসে কি হয়? ইউটেরাসের ইস্ট্রোজেন হচ্ছে অনেকগুলো কাজ করে। প্রথম কাজ হচ্ছে ইট ইনক্রিজ দ্য মাসল মাস ইন দ্য ইউটেরাস। ইউটেরাসে মাসল মাস বাড়ায়। দ্যাট ইজ পার্টিকুলারলি হেল্পফুল ডিউরিং দ্য চাইল্ড বিয়ারিং এজ। সেকেন্ড কি করে? ইট ইনক্রিজ অর দ্য প্রাইমিং অফ দ্য ইউটেরাস, by the increase the receptor for oxytocin. Why the oxytocin are required? It requires in the childbearing age to contraction the uterus and expel the child through vagina. So it help the priming of the uterus. Uterus ke priming korte help korche. That's why the oxytocin are attached with the uterus and help to expulsion of the fetus in during labor through vagina. ঠিক আছে? হার্ট অ্যান্ড লিভার, ইস্ট্রোজেন হার্টে কি কাজ করে? তুই দেখবি যে এনি হার্ট ডিজিজ মেল আর মোর এফেক্টেড than the female, because female there is a effect of estrogen which help to reduce the cholesterol, especially LDL cholesterol in the female part, and second, it prevents the atherosclerosis in the female. That's why the coronary artery disease is much more less in female than the male. Okay, and in the liver, uh, estrogen help to regulate the liver productions of cholesterol and decrease the build-up of plaque in the coronary artery. বোঝা গেল? তাহলে তোর any coronary artery disease that is less common in the female. So this is the in short the effect of estrogen in your in female part. Okay, বোঝা গেল? Now there is some diseases like that are responsible for the estrogen, that is the breast cancer. You know, estrogen when you have breast cancer diagnosis, it diagnosed estrogen positive or negative. So they have a variable outcome. Endometriosis, infertility, all are the effect of estrogen. Now what are the others? Others হচ্ছে তোর estrogen কি করে না তোর growth part of the adolescence period help করছে. Adolescence period যে growthটা হচ্ছে in male it is testosterone আর in female in estrogen. নেক্সট হচ্ছে কি অ্যাডোলেসেন্ট পিরিয়ডে যে হাইটটা আমাদের হয়, এই হাইটটা নির্ভর করে, তুই দেখবি জেনারেলি মেলে হাইট বেশি, ফিমেলে হাইট কম. হোয়াই দিস ইজ বিকজ অফ দ্য ইস্ট্রোজেন. ইস্ট্রোজেন কি করে? ইস্ট্রোজেন রেসপন্সিবল ফর দ্য আর্লি ক্লোজার অফ এপিফাইসিয়াল কার্টিলেজ. সো আর্লি ক্লোজার অফ এপিফাইসিয়াল কার্টিলেজ জন্য কি হচ্ছে, দ্যাট ইজ এ মেল আর মোর টলার দ্যান দ্য ফিমেল. আগে মনে করা হতো যে টেস্টোস্টেরন মেলে করে আর ইস্ট্রোজেন ফিমেলে করে, কিন্তু এখন নতুন যেটা হয়েছে সেখানে নাকি বলছে না, মেল ফিমেল দুটোই নাকি ইস্ট্রোজেনই করে. বাট ইন মেল পার্ট ইস্ট্রোজেন দেয়ার ফাংশন রিমেন আনসার্টেন, মানে এখনো পর্যন্ত কিছু হয়নি. বুঝতে পারলি? ওকে, দ্যাট ইজ দ্য অ্যাকশন অফ ইস্ট্রোজেন. আর কি করে ইস্ট্রোজেন? তোর একটা হয় তোর আমরা দেখি অনেক সময় কি করে ইস্ট্রোজেন তোর বিভিন্ন ট্যাবলেট বিভিন্ন সময় খাই ইন কেসেস অফ এটা চলে গেল বুঝলি. তোর ইস্ট্রোজেন দেখবি আমরা অনেক সময় ট্যাবলেট ফর্মে খাই, ভাই ওসিপিতেও ইস্ট্রোজেন থাকে এখন. তো কি হয়, ওসিপি বন্ধ করে দিলে তো আমরা যখন ইস্ট্রোজেন খাচ্ছি তখন কি হচ্ছে, ইস্ট্রোজেন যখন খাচ্ছি তখন ইস্ট্রোজেন হেল্প টু ডেভেলপ দ্য এন্ডোমেট্রিয়াল সেল, দ্য স্টোমাল সেল, অল দে আর ডেভেলপ বাই দ্য ইস্ট্রোজেন. এখন ইস্ট্রোজেন তুই বাইরে থেকে খাচ্ছিস মানে কি হচ্ছে, যে দিস এন্ডোমেট্রিয়াল যে সেল যেগুলো আছে দে বিকাম মোর টলার, স্টোমাল সেল বা এই সেলগুলো আরো মোর টলার, মোর ম্যাচিওরস. এখন দুম করে তুই ইস্ট্রোজেন খাওয়া বন্ধ করে দিলি, পিল খাচ্ছিল পিল খাওয়া বন্ধ করে দিল, তাহলে কি হবে, দ্যাট ইজ এ হেভি ব্লিডিং, বিকজ ইট হেল্প টু পলিফারেট দ্য সেল অফ দ্য এন্ডোমেট্রিয়াম. তাহলে এন্ডোমেট্রিয়াম সেল যদি পলিফারেট হয়ে যায় তাহলে কি হবে, তোর এখন তুই বন্ধ করে দিয়েছিস, তাহলে শেডিং অফ দ্য সেল হয় মেনস্ট্রুয়েশনের সময়, জানিস তো. তো শেডিং অফ দ্য সেল হলে কি হবে, দ্যাট ইজ এ হিউজ অ্যামাউন্ট অফ ব্লিডিং, দ্যাট ইজ called as the withdrawal bleeding. Okay, because আমরা estrogen খাচ্ছিলাম in form of OCP, now we stop taking estrogen and that is called the withdrawal bleeding. Okay. So this is the in short of estrogen. নাও there is a ভেরিয়েবল এফেক্ট। আমি তো আগের দিনও মানে এখনই বললাম যে মেন্টাল উইলনেস, বললাম তো ফিমেল সাইকি যেগুলো আছে, ফিমেল ক্যারেক্টারিস্টিক সব, আর স্কিন অ্যান্ড হেয়ার প্রবলেম অল আর ইস্ট্রোজেন। নাও স্লিপ অ্যান্ড প্যাটার্ন, ইস্ট্রোজেন প্যাটার্ন, তুই দেখবি যারা পোস্ট মেনোপজাল ওমেন তাদের দেখবি স্লিপ ডেপ্রিভেশন হয়, মানে তাদের স্লিপ প্যাটার্নটা চেঞ্জ হয়ে যায় বিকজ অফ দ্য ইস্ট্রোজেন। digestive problem, okay. Now fertility problem to the hobby জানিস, muscle আর bones তো পড়ানো হলো। নেক্সট দ্য ওয়েট অ্যান্ড ফ্যাট, দেখা গেছে কি ইস্ট্রোজেন কি করে, ইস্ট্রোজেন রিটেনশন অফ সোডিয়াম অ্যান্ড ওয়াটার ইনটু দ্য বডি, so that's why the it is seems that the in premenstrual period, মানে like before menstruation 1 to 2 days, the weight of the female body increases because estrogen retains the sodium and water into the body, okay. So body temperature and তোর হার্ট হেলথ পড়ানো হলো। বডি টেম্পারেচারটা একটা তোর ভালো ইয়ে আছে, সেটা হচ্ছে আগে যখন আমাদের ওসিপি ছিল না তখন মেয়েদের কি করে তোর কন্ট্রাসেপশন মানে সেফ পিরিয়ড কি করে ক্যালকুলেশন করা হতো, it is seen that the effect of estrogen, the body temperature of female increases 0.5 degree to 1 degree centigrade during the ovulations. Then ovulating days মানে 14 days দেখা গেছে ওই সময় মেয়েদের বডি টেম্পারেচার 0.5 to 1 ইনক্রিজ করে। So after that come to a danger period, before that is the safe period. So this way when the OCP are not in the market, that's way we they can calculate the safe period and the unsafe period, okay. So that's why the temperature it is important, okay. Now come to the progesterone. ইস্ট্রোজেন যা কাজ করে প্রোজেস্টেরন তার উল্টো কাজ করে, ঠিক আছে, এটা মনে রাখবি, তাহলে মোটামুটি পরীক্ষার সময় প্রোজেস্টেরন কিছু লিখে আসা যাবে, ঠিক আছে, মনে না থাকলেও, ঠিক আছে। তাহলে প্রোজেস্টেরন তাহলে কি কাজ করছে, প্রোজেস্টেরন তোর প্রথম ইয়ে কি বললাম যে ইট ইজ ইস্ট্রোজেন কি করছে, দ্য কন্ট্রাক্টিলিটি অফ দ্য ইউটেরাস বাড়াচ্ছে, তাহলে প্রোজেস্টেরন কি করবে, কন্ট্রাক্টিলিটি অফ দ্য ইউটেরাস কমাবে। তোর পারফেক্ট এক্সাম্পল কি আছে, প্রিমেনোপজাল ক্র্যাম্প। প্রিমেনোপজালে কি হয়, বিফোর মেনস্ট্রুয়েশন সার্কেল প্রোজেস্টেরন কনসেন্ট্রেশন ড্রপ, as progesterone concentration drop, estrogen take the upper hand. As the estrogen take the upper hand, estrogen cause increased contractility of the uterus, and this cause the premenstrual cramp in the female. This is the perfect example of তোর progesterone, ঠিক আছে। Another clinical example is the we can use the abortifying agent like mifepristone. mifepristone কি করে, ইস্ট্রোজেন বেসিক্যালি কি করে বলতো, ইস্ট্রোজেন কাজ হচ্ছে বাচ্চাকে ধরে রাখে। ধর একটা ওভাম ফার্টিলাইজ হলো, দিয়ে জাইগোট তৈরি হলো, জাইগোটটা কোথায় ইমপ্লান্ট হবে, ইন দ্য ইউটেরাইন ক্যাভিটি, তাই তো, এখানে ফার্টিলাইজ হলো, ফার্টিলাইজ হয়। এবারে যদি ইস্ট্রোজেন তার আপার হ্যান্ড নিয়ে নেয়, ইস্ট্রোজেনের কাজ কি হবে, ইস্ট্রোজেনের কাজ হবে ইট ইনক্রিজ কন্ট্রাক্টিলিটি অফ দ্য ইউটেরাস। তাহলে যদি ইউটেরাসটা কনস্ট্যান্টলি কন্ট্রাক্টাইল হয়ে যায়, তাহলে ওই যে জাইগোটটা ইন দ্য ওয়াল অফ দ্য ইউটেরাস ইমপ্লান্ট হলো, ও কি থাকতে পারবে, ও তো বিকাম ডিসলজ অ্যান্ড নট গো থ্রু। Progesterone কি করছে, it decrease the contractility of the uterus, that help to implant the zygote in the wall of the uterus, বুঝতে পারলাম। আর একটা কি করে প্রোজেস্টেরনের কাজ, এগুলো সবই হচ্ছে তোর মানে ক্লিনিক্যাল সিনারিও। এনি ফার্টিলাইজড ওভাম একটা ইন ফিমেল বডি, দ্যাট ইজ দ্য ফরেন, তাই না, যে তার প্রথম বাচ্চা হলো, তার আগে বাচ্চা হয়নি, তাহলে দ্যাট ইজ দ্য ফরেন স্ট্রাকচার ফ্রম দ্য ফিমেল। তাহলে ফিমেল বডি কি করবে, they start to generate the inflammatory mediators, B cell, T cell, all that stuff to destroy this foreign material and to just pass with it. Progesterone ki kore, in that time it decrease the immunosensitivity of the female uterus. ওইখানে তোর ইমিউনোসেন্সিটিভিটিটা কমিয়ে দেয়। That's why the immunological reaction not develop against the zygote. That is the main three action of progesterone in cases of estrogen. ঠিক আছে, তাহলে ইস্ট্রোজেন প্রোজেস্টেরনের পার্থক্য কি হলো না, ইস্ট্রোজেন improve in the reproductive development in female, আর প্রোজেস্টেরন কি করে, স্টেরয়েড হরমোন দ্যাট প্রিপেয়ার দ্য ইউটেরাস ফর দ্য প্রেগনেন্সি। বোঝা কেন হলো, কি করে প্রেগনেন্সিতে হেল্প করে বোঝালাম তোকে, বাই দ্য থ্রি ওয়ে। নেক্সট হচ্ছে প্রোডাকশন অফ গ্রোয়িং গ্রাফিয়ান ফলিকল, গ্রাফিয়ান ফলিকলকে প্রোডাকশনে হেল্প করছে। আর এ কি করে, প্রোডাকশন অফ দ্য কর্পাস লুটিয়াম। থার্ড, সো তোকে যদি প্রশ্ন করে পরীক্ষার সময় যে হোয়ার দ্য ইস্ট্রোজেন আর সিক্রেটেড from the Graafian follicles, however the progesterone are secreted from the corpus luteum and the placenta. Okay, now estrogen are secreted by the ovary prior to the ovulations, also produced by the placenta during pregnancy, are secreted by the ovaries after the ovulations. প্রোজেস্টেরন ওই যে বললাম, আফটার যখনই বাচ্চা এলো তখন প্রোজেস্টেরনের কাজ শুরু হলো, বাচ্চা আসেনি প্রোজেস্টেরনের কাজ খুব বেশি নেই, তখন ইস্ট্রোজেনের কাজ। অ্যান্ড অলসো প্রডিউসড বাই দ্য প্লাসেন্টা ডিউরিং প্রেগনেন্সি। হলো সিক্রেটেড রেগুলেশন বাই এফএসএইচ, আগেই বলেছিল যে এফএসএইচ সিক্রেশন করে ইস্ট্রোজেন আর এলএইচ সিক্রেশন করে প্রোজেস্টেরন। ঠিক আছে, আর ইনভলভমেন্ট ইন দ্য ফরমেশন অ্যান্ড মেনটেনেন্স অফ সেকেন্ডারি সেক্সুয়াল ক্যারেক্টার বলে দেওয়া হয়েছে। প্রোজেস্টেরন কি করে, ইনভলভ ইন আ ফরমেশন অ্যান্ড মেনটেনেন্স অফ এন্ডোমেট্রিয়াম অ্যান্ড ইউটেরাস। ঠিক আছে, involvement is the enlargement of the uterus and breast during pregnancy. Progesterone কি করে, involvement in the reduction of the contractility of the uterus and stimulus for the growth of mammary gland, which after conception it helps the formation of the mammary gland enlargement, so the breast milk production are increased during lactating period. That is the difference between the estrogen and progesterone. ঠিক আছে, তো এটাই তোদের নিয়ে এসেছি যে ফার্টিলাইজ হচ্ছে ইন দ্য ইমপ্লান্ট হচ্ছে ইন দ্য তোর wall of the uterus. So how the progesterone work, it is produced by the ovary, adrenal and placenta. তোকে আগেই বললাম যে ইন দ্য প্লাসেন্টার ফার্স্ট 10 উইক্সে তৈরি হয় না, তারপর যখন প্লাসেন্টা ডেভেলপ করে যায় তখন ফুল অ্যামাউন্টে তৈরি হয়। অ্যান্ড প্রোজেস্টেরন স্টিমুলেট দ্য এন্ডোমেট্রিয়াম টু রিসিভ অ্যান্ড নারিশ অ্যান্ড ইমপ্লান্ট ফার্টিলাইজড এগ। প্রোজেস্টেরন কি করে, প্রোজেস্টেরন আফটার কনসেপশন প্রোজেস্টেরন কি করে না, তোর stimulate the ovary and the uterus to stimulate some secretion, and this secretion help to nourish the developing zygote. Okay, so this is their functions. If implantation does not occur, progesterone level drop and the endometrium breakdown and menstruation occurs. যেটা বললাম ওই তোর আগেরটাই পরেরটাই, এই যে formation of corpus albicans. And if the pregnancy occurs, progesterone is produced in the placenta throughout the pregnancy. বোঝা গেল? So this is in short the estrogen and progesterone in our in the female body. Okay, এটা হচ্ছে তোর প্রোজেস্টেরনের রোল। হ্যাঁ, বোন তোর ডেন্সিটি মেনটেন করে, তারপর রিপ্রোডাক্টিভ ফাংশনকে মেনটেন করে, অ্যাসিস্ট দ্য লিভার অ্যান্ড কিডনি হেলথ। হ্যাঁ, এগুলো মেয়েদের মাথা নাকি ঠান্ডা হয় বলে, তো ঠান্ডা ঠান্ডা করে দেয়। সো অল দ্যাটস দ্য এফেক্ট অফ ইস্ট্রোজেন। কি তাহলে গরম করে দেবে? সো দ্যাট ইজ দ্য এফেক্ট অফ তোর প্রোজেস্টেরন ইন ফিমেলস। নাও last part, it is the HCG. What is the full form of HCG? Human chorionic gonadotropic hormone. ঠিক আছে, HCG। তাহলে HCG এর সঙ্গে প্রথমেই বললাম যে HCG হচ্ছে তোর in the where it is secreted from a syncytial trophoblast, and it is appears in the urine in the days of 9 to 10, and concentration has steadily increased up to 10 to 12 weeks. After that, estrogen progesterone take the upper hand and it down regulation the HCG. ঠিক আছে? Now you know there is a, when you are in gynae class, so placenta, that is the placenta is itself a endocrine gland in the in that context. So because placenta, it is secreted HCG, it is secreted estrogen, it is secreted progesterone, all that is are secreted from the placenta. So placenta তোদের পরীক্ষার সময় যদি পরীক্ষায় প্রশ্ন আসতেই পারে যে প্লাসেন্টা, what is the in hormone that is the secreted from the placenta. So there is just few short note about regarding the placenta. ঠিক আছে? So you know the placenta, it is few hormone that is are secreted from the placenta. Okay, so that is the placental estrogen, placental progesterone, placental HCG. তো এগুলো কিন্তু পরীক্ষার সময় পড়তে হবে। নেক্সট একটা হরমোন আমি বাদ দিয়ে গেছি, সেটা হচ্ছে রিল্যাক্সিন। রিল্যাক্সিন ইট ইজ দ্য হরমোন দ্যাট ইজ সিক্রেটেড ডিউরিং চাইল্ড বার্থ। রিল্যাক্সিন কি করে? রিল্যাক্সিন ইট সিম্ফাইসিস পিউবিসকে, মানে পিছনে যে বোনসটা থাকে, দ্যাট help to relax the symphysis pubis, and it help to relax the other pelvic joint in the female body that help during the labor. ঠিক আছে? নেক্সট কি করে? নেক্সট হচ্ছে ইট softening the uterus and the vagina during the labor. তাহলে কি হচ্ছে? it augment the labor. So there is a two things. One, it is the symphysis pubis কে তোর স্ট্রেচ করে বা রিল্যাক্স করে। সেকেন্ড হচ্ছে সফটেনিং অফ দ্য ইউটেরাইন ক্যানালস অ্যান্ড ইন দ্য ভাজাইনা। অ্যান্ড থার্ড পার্ট কি করছে? ইট inhibits the uterine contraction. All these are responsible for the augmentation of the labor. That is the action of relaxin in female. Okay. So this is in short the action of physiological effect of sex hormones. এবার তোদের কিছু জানা থাকলে বল। আর তোর প্লাসেন্টাল এইচসিজি বলে দিলাম, আর প্লাসেন্টাল ইস্ট্রোজেন প্রোজেস্টেরনের কাজ হচ্ছে সেম, মানে নর্মাল যে ইস্ট্রোজেন কাজ করে আর নর্মাল যে প্রোজেস্টেরন কাজ করে, দ্যাট ইজ দ্য তোর প্লাসেন্টার ওই যে প্রোজেস্টেরন কাজ করে সেখানে তোর একই মোটামুটি কাজ করে, বুঝলি তো? এবারে ইস্ট্রোজেনের প্রজেস্টেরনের আরেকটা কাজ করলো তোকে, ওই যেটা বললাম না, ওই মিফিপ্রিস্টোন, প্রজেস্টেরনের কি হয়, mechanism of action estrogen progesterone. As we know, the all are lipid soluble hormone estrogen progesterone. The lipid soluble hormone কি হবে, they direct enter into the cell as it dissolve into the cell membrane. Lipid soluble hormone, cell membrane made of lipid, into the cell and it attached with the nucleus, and in the nucleus they stimulate the DNA to produce the mRNA, and this mRNA responsible for the protein synthesis, and these protein are responsible for the action of estrogen and progesterone. Okay, in case of progesterone there is a receptor regulation, that is called the heat shock protein. কি হয় না, যখন প্রজেস্টেরন এসে ডিএনএ এর সঙ্গে লাগে, there is a gap in the DNA and the heat end of the heat shock protein are now closed, but in normal resting condition. But when the progesterone get attached, now the heat shock protein of the DNA part is now exposed, and this way we can use the other agent like mifepristone and all the stuff to produce or the produced of the increased contractility of the uterus, and that's why the mifepristone act as a abortifying agent. ও কি করছে, প্রজেস্টেরনের যে রিসেপ্টর সেখানেই লাগছে, কিন্তু সেখানে অলরেডি প্রজেস্টেরন লেগে আছে। ও কি করছে, ওর যে হিট শক এন্ডটা আছে, যখন যেটা প্রজেস্টেরনের পর যেটা এক্সপোজড হয়ে যায়, ও এইখানে এসে লাগে, ফলে কি করছে না, ওই প্রজেস্টেরনকে বাদ দিয়ে বাকি যে কন্ট্রাক্টাইল পার্ট অফ দ্য ইউটেরাস সেটাকেও রেগুলেট করছে। ঠিক আছে, আর প্রজেস্টেরনের আরেকটা কাজ কি হচ্ছে, প্রজেস্টেরন যে তোর সিক্রেশন করে না, all this secretion all are basically a thick secretion, but the estrogen আমি কি বলেছিলাম, there is a thin secretion and they produce a fan like pattern in the vagina, but in case of progesterone they secrete a thick substance, and this thick substance are prevent the sperm to enter into the uterus. So basically কি করছে না, তোর প্রেগন্যান্সিতে মানে ইনহিবিট করছে বা বাধা দিচ্ছে, তাই তো। তাহলে মোটামুটি তোদের ইস্ট্রোজেন আর একটা কি হচ্ছে, ওই যেটা বলা হলো না তোদের, ওই ইস্ট্রোজেন যেমন কি করে সোডিয়াম আর ওয়াটার রিটেনশন করে, প্রজেস্টেরনের কাজ হচ্ছে উল্টো মানে হচ্ছে ইট অ্যাক্ট as a diuresis মানে কি করছে, to expel the sodium and water from the female body. আর একটা কি করে, it decrease the CO2 concentration in the lung in female. CO2 concentration কি করে তুই জানিস, যে ডিউরিং লেবার কি হয়, মেয়েদের অ্যাবডোমেন প্রচুর হয়ে যায়। তুই জানিস এনি now our topics comes out with the obesity hypoventilation. তোরা যখন মেডিসিনে সব বড় বড় ডাক্তার হয়ে যাবি, হ্যাঁ, তখন তোরা সব পড়াবি, হ্যাঁ, আমরাও শুনতে যাবো। সো ওবিসিটি হাইপোটেনশনে কি হয়, দেখ বেসিক্যালি কি হয়, আমাদের যে নিঃশ্বাস নিই কে নামে, ডায়াফ্রাম ওপর নিচে করে। এখন দেয়ার ইজ যে ইনক্রিজ ওবিসিটি, তাহলে কি হবে, ডায়াফ্রামের মুভমেন্ট কম হবে। ডায়াফ্রামের মুভমেন্ট কম হলে কি হবে, আমাদের inspiration expiration কম হবে, and there is a retention of CO2 in the body, which equivalent to during pregnancy. পেটের ইউটেরাসটা বড় হয়ে যাচ্ছে, মেয়েদের পেটটা এত বড় হয়ে যাচ্ছে, তাহলে কি হচ্ছে, there is a decrease diaphragmatic movement, and there is a retention of CO2 in the female body. progesterone help to diminish or to reduce the CO2 retention during the labor. That is the one of the most characteristic action of estrogen in the human. Okay. So this is in short your the physiological effect of sex hormone. তাহলে in summary যদি পরীক্ষায় প্রশ্ন আসে তাহলে তোমাকে মেল ফিমেল আলাদা করতে হবে, একসঙ্গে লিখে দিলে মুশকিল। মেলে তোমাদের টেস্টোস্টেরন অ্যান্ড ইনিভিন, মেয়েদের ছেড়ে দেবে একটা সিম্পল, মেয়েদের একটা কমপ্লেক্স। মেয়েদের একটা কী করতে হবে তোমাদের, there is a 5 or 6 hormones, FSH, start from FSH, LH, then estrogen, progesterone, then relaxin, and lastly যদি সময় থাকে তাহলে বিটা এইচসিজি। দিস 6 হরমোনস অল্প অল্প করে লিখে আসলে মোটামুটি পরীক্ষায় ভালো নাম্বার পাওয়া যাবে। ঠিক আছে। আর ইস্ট্রোজেন আর প্রজেস্টেরন মনে রাখবি দে আর অপোজিট অ্যাকশন। যদি পরীক্ষায় ইস্ট্রোজেনটা পড়ে গেলাম, স্যার ইস্ট্রোজেনটা পড়েছি প্রজেস্টেরনটা পড়িনি, কোনো ব্যাপার নেই। যদি নাও পড়ে থাকিস, ইস্ট্রোজেন যদি পড়ে থাকিস বা প্রজেস্টেরন যে কোনো একটা পড়ে থাকলে প্রজেস্টেরনটা উল্টো করে দিবি, তাহলেই হয়। দ্যাট ইজ দ্য অ্যাকশন অফ প্রজেস্টেরন। ঠিক আছে, বল এবার কারো কোনো কোয়ারি আছে?
Yet once again, we are here to continue the learning on these embryological aspects of GI system development, and we learned and talked about this basic phenomenon of GI system learning, that involving this GI system growth, we have 3 basic phenomena which helps us to understand this particular development of the tracts. So we talked about it's a kind of like a 3 different phenomena which helps us to identify the GI system development. One is dilation. That means the tube which is formed is going to form some kind of dilations or enlargements. That's what we have seen in case of the stomach formations, which is a growth or the differential growth we have seen in the stomach, which is dilated sac-like structure is produced. Other thing we mentioned about is budding. That means it's some outpouch is going to happen, and from that particular outpouch it is going to create some organs, like all these GI organs, livers, pancreas, gallbladder, they are going to be produced like that. And we have left with another phenomenon, we call them as elongation. That means this particular tube, which was like 5 centimeter in length, becomes 50 centimeter in length by elongating it. So that's a 3 phenomenon which is going on. So we have seen this particular dilations, how this particular differential dilations takes place in case of this particular stomach. And today we are going to emphasize the phenomenon of the organ development of this foregut region. So we have divided this particular gut region development into foregut, midgut, and the hindgut. We have different blood supply for each component of this gut, and we understand how much is foregut, how much is midgut, and hindgut eventually. So we have entered to learn about this particular foregut. We learned about this particular stomach development. We are proceeding in the same foregut region. We are going to finish this particular foregut development today. Now, before we proceed again, we give this particular, it is a tube which is going to go some outpouch or pouch-like projections. We call this phenomenon as what is produced, we call them as bud. So from that particular bud, if any organ is coming out, we call them as hepatic bud. If it is coming out to be the gallbladder, we call them as cystic bud. If it is going to be forming about the pancreas, we call them as pancreatic buds, likewise. Now, if you just like understand this particular pouch, it has 2 components. One component is this one, and other component is this one, which I am shading it. So this is the out pouch which you see here. We call them as A, which is this sac-like structure is formed over here. And next is that the part over here, we call them as B part. easy to understand this development of the rest of this particular organ development. So each of this particular outpouch, we call them as bud, has got two parts. One is A, which is the sac-like structure itself. We call them as outpouch bud. And the B part, this particular region is connected, which you have named as B part. We call them as connection part. Now this particular connection part in the ducts. So these things form the duct system of that particular organ that is going to be, and this particular A part forms the organ itself. This pouch sac-like structure, and what is this particular connections? We are going to build this particular today's topic of the GI system development of the foregut and foregut organs itself. So this is a quick recap. We have learned this particular histological mucosa, submucosa, muscle layer, and the serosa. And this out of this mucosa have got three components. Only this yellow part, that means cells and the glands, which is present in here, is endodermal. And this particular endoderm comes here from this particular yolk sac tube. So this particular gut, in small words, whatever this intestine we have is developed from this yellow structure, incorporated. We call them as yolk sac tube incorporated, forms this particular tube like this eventually, which has a connections. We call them as vitalo-intestinal duct. That connection should be completely absorbed. If it fails to absorb, we have a disease. We talk about this particular unabsorbed part of the vitalo-intestinal duct as a disease component later on. So this is what we have learned, and we have learned about this particular intestine covered by this membrane. We call them as mesentery, ventral and the dorsal part. We understand what is ventral and what is dorsal. And this particular dorsal, which is present on the back side, is extensive compared to this ventral one, which is only present in this narrow strip regions. And we understand how this particular narrow strip, this particular lesser omentum and falciform ligament contributes from this particular ventral mesentery. And this particular foregut tube has got, each of them have got individual blood supply. We already have understanding on this. And this particular tube, we call them as foregut tube, starting from the esophagus, ending on the upper part of the duodenum. This much of stretch, we call them as foregut for foregut derivatives. Now, this particular region, esophagus and the stomach development, we have taken care of. Stomach is having this particular differential growth of this particular different walls is taking place. With these rotations, we have this particular phenomenon, which is, we have seen this particular change of names of this vagus nerve, which is taking place, change of this particular curvature, which also is taking place, and this creating this particular space behind the stomach. We call them as lesser sac, which has been produced by this. And this particular positional change in case of anteroposterior axis, because of this rotation, tilting of the stomach is taking place to accommodate more fluid or more food particle inside this particular stomach, so that this particular gastric emptying can be controlled or released depending on. So this much we have learned. And diseases of this particular stomach, which is known as the hypertrophic pyrolytic stenosis, from that we have already learned about. Now this is what we have moving into the formations of this liver, gallbladder and the pancreas, which you will be going to learn. Now as I mentioned, this particular organ formations in the GI region takes over or forms because of the budding of this particular tube. So if you pay attention to this particular picture, so we can explain that later on. You see that this particular black shadow, which is coming at this particular lower end of the foregut tube, this orange tube, which is a foregut tube or the gut tube, and this particular lower end of this particular foregut tube, we have a black shadow. So this particular black shadow or this particular element is a bud which is coming out. So this particular bud which is coming out is future destined to be the liver, and this bud we call them as hepatic bud. So this black shadow we call them as hepatic bud, which is this one, like outpouch. Now this particular bud, as we have learned, is growing into this tissue which is present in here. We call this particular tissue which is intervening between this cardiac region and this abdominal region as septum transversum, which is a mesodermal element or mesodermal tissues, which was there in this particular region. With this particular folding, it has pushed down into this particular region and making this partition. this septum transversum is largely contributing to the formations of the diaphragm, which is the central part of the diaphragm is concerned, forming this particular pericardium as well. So this particular septum transversum, which is a connective bridging tissue which is present in here, this particular black tissue grows or infiltrates into it. So this hepatic bud, which is the black tissue, grows into this connective tissue, we call them a septum transversum, and grows and fangs out. So if you see this particular tissue, orange one, and this particular tube into this particular black tissue, this particular element grows over here. So compared to the A picture to the B picture is that this particular black tissue which you are seeing here, the bud, slowly grows more and becomes enlarged. So this particular black shadow which is much more enlarged from A picture to B picture. So the septum transversum accommodating this particular growth of this particular black tissue, we call them as the hepatic bud, which is going to be the future liver for us. Now, taking down from here, this particular bud into this, and everything is excluded out. You can see this. This is hepatic bud, which is growing into just like a branching pattern into the septum transversum. And this particular bud has a B part, which is known as the connecting part. This particular connecting part, we see that as connection B like this, becomes the duct system. This B part, which is a connection, forms the duct system. We call them as bile duct. Now, in case of this particular liver morphology, if you can remember that this duct system consists of this particular Y. We call this as hepatic bile duct. The hepatic bile duct has a right side and the left side, right and left hepatic bile duct makes this particular common bile duct or common hepatic bile duct, which eventually gets a sub-branch duct as this bile duct system, which is hepatic bile duct, is formed from this particular channel, from this particular channel over here. So this particular bud has got two components. This is the main bud, which is, and this is the connections. The connections in future becomes this particular thing, which is hepatic bile duct or this common hepatic bile duct, and this particular bud itself grows into these liver tissues. Now, if you just break down this particular liver tissue, whatever you have learned in histology, we see this histologically, liver tissue have got three components. So this liver tissue has an element, we call them as parenchyma. So what is parenchyma? Nothing but this particular cells which is present in here. What cells present in here is the hepatic cells. We call them as hepatocytes. Second element, which is the spaces lined by the endothelial cells, which is lying between this parenchyma. So if it is a central canal is there, this particular hepatocytes are arranged like this. In between them, we have this gap which is lined by this thin endothelial cells. We call them as sinusoidal spaces. And third element which this particular liver has is capsules and other cells than parenchyma. That means connective tissue cells, that means defense cells plus cells. So these are the three functional or structural component of these liver cells we have. Now what transforms into here from this different component over here? We have this particular liver bud which is growing in here. This liver bud grows into cells or hepatocytes. So this parenchyma is developed from the hepatic bud. What is hepatic bud? We understand that. Now this particular sinusoids and this particular capsules are largely contributed from the septum transversum. What is septum transversum? Which is a mesodermal element into which this bud goes. So this particular sinusoids are broken down or formed or created from some vessels. What vessels we are going to see? And this particular capsules and the cells other than hepatocytes, that means the defense cells, that means which is producing this particular defense actions in this particular liver, we call them as Kupffer cells. They are produced from this particular ST, that means septum transversum. So let's bring it down to see that what are the components of this liver cells has. Now you see that this particular element into here we have this septum transversum. Within this septum transversum, there are two blood system or blood channel existing in this embryonic phase of development. We have this sinus venosus which is formed over here, this particular sinus venosus, which is the embryological component for the formations of this particular cardiovascular system, is contributed by these two vascular channels which is coming from the bottom side. This bottom side venous channels, we call them as vitelline veins and umbilical veins. We have right side and left side, a pair of these particular veins are there. This particular veins comes from the lower part of the embryo and drains or passes through the septum transversum. So this septum transversum is this tissue which has been removed over here, only leaving these vascular channels in here and residing over this place. So this particular vascular channels which are present in here, they are infiltrated by this particular hepatic buds. And eventually, these particular channels which is present within the septum transversum are broken down into this particular fragment like this. And this particular fragment over here, we call them as hepatic sinusoids. So these veins which is present in here, we call them the vitelline and umbilical vein, right side and left side. A pair of them are broken down into this particular sinusoids, and we understand what do you mean by the sinusoids, that the space between this particular parenchymas. So this is how these particular sinusoids are contributed by the fragmentation of the bones which is present in the septum transversum, which is vitelline veins and this particular umbilical veins. Rest is that we have only thing which is left over here, the septum transversum itself contributes the capsules of the liver. Liver is covered by a capsule, so we call them as Glissen's capsule, which is slippery, which is kind of shiny. That particular Glissen's capsule, which is wrapping around this particular liver cells or this particular liver region, along with this particular defense cells of the liver, we call them as Kupffer cells. They are not parenchymal cells. They are not coming from this particular entity, which is contributed from this. So this particular septum transversum, which is contributing to these particular formations of these particular capsules, which is the Glissen's capsule plus Kupffer cells, and along with this particular sinusoids which is coming from this particular umbilical vein and vitelline vein. So these particular liver is taken from in piece mesodermal element, endodermal element, making together and forming this entire liver. So if you just like break down into simple words, liver have got three different components, and from three different sources it is bringing to form this entire liver. One is this parenchyma, that means liver cells. The liver cells comes from the endoderm, that means hepatic bud. Other than this, liver have got sinusoids. That particular sinusoids is contributed by these fragmentations of these umbilical and vitelline veins. And it has capsules, and these non-parenchymal cells, non-hepatocyte cells, defense cells, they are coming from the septum transversum itself, this particular tissue into which this liver bud grows and eventually gets into it. So this three functional component forms in this particular liver. Along with that, the bile system that we have contributed. The bile system have got two major channels, right and left hepatic bile ducts and common hepatic ducts, which is coming and uniting together, coming as, so that particular element is coming from this particular connections of the bud which is contributing to it. So this is how this entire liver and components of the liver is contributed. Taking from the liver, we are moving to this particular gallbladder. For the gallbladder, we have to understand and zoom this particular same picture once again. You see that this is the formations of this stomach, which is forming the tube again, and this hepatic bud is going, and this particular hepatic bud connection, we call them as the connection point, which is going to be this particular bile duct. And this particular bile duct is present or related to this particular liver, we call them as hepatic bile duct. Now this particular hepatic bile duct, at some point, it shows another outpouch or another bud. This particular another bud, which is growing into the ventral mesentery, we call them as cystic diverticulum, because that particular cystic diverticulum or the cystic bud is going to form the liver, going to form the gallbladder. And again, taken from this particular cystic bud, which is this particular bud is there, which is coming from this particular growth over here, has got two parts. This is the main sac and this is the connection point. So this particular connection point over here is formed or contributing to this particular cystic duct, and this whole thing is going to form the gallbladder. So the gallbladder have got few parts. We call them as fundus of the gallbladder. Then we have the body of the gallbladder and we have the neck of the gallbladder. If you see this particular gallbladder morphology, if you're looking at them as fundus, then you have the body, then you have the neck, then we have this particular duct which is going to join the cystic duct. So this entire from this particular sac structure, that is this cystic duct is there, and then we have this particular whole thing which is the duct system, which is the cystic duct is formed from this particular connection point. So this is how this gallbladder is formed, cystic diverticulum, also known as cystic bud, and then we have this particular channel of this particular gallbladder which is known as cystic duct, which is formed from this particular connection point of this particular duct system. So this is how the entire thing of this gallbladder and this particular liver cells or these particular liver components are formed. We have to talk about another organ to develop from this particular same component. We call this as the pancreas. Now the story of the pancreas development is little complex and little bit different than that of this particular liver development and this particular gallbladder development. So little bit is kind of like a complex compared to it. So again we are moving back to this particular same picture as I am projecting in here, which is this particular joint, which is the lower end of this particular foregut tube where the stomach has end, and this particular duodenum is going to form, and this particular distal end we have this particular hepatic bud and the cystic bud is coming on. So as this two growth of this particular hepatic structure and this gallbladder structure is going on, we have a generation of another projections like this. So you see that we have a projections coming from this particular connection point of this particular cystic bud with this particular proximal part of this distal part of the foregut tube, which is another outpouch is coming on from these particular projections. And on the back side, which is on the dorsal side, we call them as dorsal mesentery side, we have another pouch which is directly coming from this particular foregut tube. So this particular projection is a little late in formation compared to this particular gallbladder and the cystic bud. So if it is forming like a week 4, day 1, day 2, this is coming like week 4, day 5, day 6, around that time, little bit delayed, but it is coming out as a projections, or again same thing as budding. So there are two buds which is coming, which is going to form the future pancreas as we are going to talk. Now before we go to this particular budding and for the maturations of this bud, we have to understand different parts of this particular pancreas, which we already know like to go through this particular pancreas. So this pancreas, which is an organ, which is having spanning over this particular back side of this particular posterior abdominal wall, have got few parts. Now the parts of this pancreas, we call them as a head of this pancreas, and under the head, we have a projection, we call them as hook. That hook of the pancreas, we call them as uncinate process. Then we have this particular splenic tissue towards this particular region, we call them as tail of the pancreas. Now this particular pancreas is pierced by the duct system. We call them as pancreatic ducts. So we have two sets of the duct which is present in this particular pancreas as a main pancreatic duct, which is this particular pancreas, and we have an additional pancreatic duct. We call them an accessory pancreatic duct, like this. Ducts A and B, which is present, the main pancreatic duct, which is piercing the pancreas from this particular head end to this particular tail end. Now, this particular main pancreatic duct or around that particular point and drains to a common point, we call them as ampulla of Vater guarded by a sphincter of Oddi, which is opening into the junctions of this particular first part and the second part of the developmental region of the duodenum. Now, this particular pancreas, embryologically, we split this pancreas for the developmental region into two parts. This head region of the pancreas, we split into two parts. One is so the superior part, we call them as the upper part of the pancreas, and the lower part of the pancreas of the head. So this particular head region of this pancreas, which is the lower part of the head, has this projection we call it or the lower part of the pancreas uncinate process goes as a single unit. So this region uncinate process plus lower part of the pancreatic head is together and rest is together. So these differentiations will make sense as we progress through this development of this particular pancreas, which you're going to do. To start with this pancreas, as I am saying, this particular pancreas initially was two. There are two buds which is coming on in this particular region, one region to this particular cystic bud region and another on the ventral side of this particular Foregut tube is coming on. We call them as bud, and we call them as ventral pancreatic bud and dorsal pancreatic bud. So initially we had two pancreas to develop, but eventually we had to make it one. So this pancreatic bud to start with was two. We call them as ventral, which is a blue color as you are seeing here, and this particular red one is the dorsal side. We call them as dorsal pancreatic bud. So two buds are there. And if you can see this particular comparative picture, this particular ventral one is smaller compared to this particular dorsal one. As the time progresses, you can see that the difference is much relevant. The ventral one is a smaller, skinny one, and this dorsal one is enlarged and growing big, because the space on the back side was much more than that of this particular ventral side, because this particular gallbladder is growing, the liver is growing. So as a result of this, this front side of this particular pancreatic tissue bud region was scanty in space. Compared to the back side, it was an empty field. That's why this particular posterior pancreatic bud, which is known as this particular dorsal pancreatic bud, grows more freely and grows more bigger. Now, this particular ventral pancreatic bud and the dorsal pancreatic bud, as it was growing together, eventually it was interrupted by this particular movement of the stomach. So what movement of the stomach? We have this particular movement of the stomach. We call them as rotations of the stomach. We talked about this particular clockwise rotation, 90-degree stomach takes place around 5th week of life. So this particular stomach rotates because of the clockwise rotations, and as a result of this, this particular ventral pancreatic bud switches or swings below and under this particular dorsal pancreatic bud. Because of this particular rotations of the stomach, swings this particular thing. Now, what happens from this A, B, this is the C sequel which is happening with this particular pancreas. So this is what this particular ventral and dorsal is going on. With this particular movement, this of the stomach and this duodenum, this ventral one swings below and under this particular growing dorsal pancreatic bud and comes closer with each other and moves to the similar side. So they move together, migrate towards the posterior side because of the rotations of the stomach along with the duodenum. And they come close. And as a result of their coming together, they club and join and make a single pancreatic bud eventually. So initially, to start with, there are two pancreatic buds are there, ventral and dorsal. Later on, with the movement of the stomach, this particular ventral one moves backside and under to this particular dorsal pancreatic bud and eventually fuses to become one. Now, this particular ventral pancreatic bud has a duct system. The dorsal pancreatic bud also has a duct system inside. So we call them as ventral pancreatic duct and dorsal pancreatic duct. Now, once this particular fusions of this particular ventral and dorsal pancreatic duct, what happens eventually afterwards? So this particular thing which is joined together forms it and forms a single pancreas. So this blue one, we call them as ventral pancreatic bud, contributes to the lower half of the body of the pancreas, head of the pancreas with the uncinate process. So from this particular dorsal pancreatic bud, which is the blue one, contributes a small fragment of the adult pancreas. What is that part? Upper part of the head, body and the tail, which is coming from the all of it. The ventral one, which was in the front side, which is the ventral pancreatic bud in the blue, contributes to the uncinate process and the lower part of the head. So this part, lower part of the head and uncinate, which is shaded over this purple line, they are contributed from this particular blue one, which is known as ventral pancreatic bud. And the rest of the pancreas, that means the upper part of the head, neck, body, tail, is coming from the posterior one, all dorsal pancreatic bud. So this particular pancreas, which is formed like this, ventral and dorsal, eventually becomes one, and the ventral one contributes to this particular uncinate process and lower of the head, and dorsal one contributes to the rest of the pancreas. Everything which is left in here is formed from there. Now coming to the duct system, as I mentioned, the pancreas has two ducts. One is the main pancreatic duct, that means it is running throughout the length of it, and other is accessory pancreatic duct. So this particular dorsal pancreatic bud has a duct inside. We call them as dorsal pancreatic duct. And the ventral one also has a duct. We call them as ventral pancreatic duct. Now this particular duct system which is present also unites or exchange between them. What happens over here? So this particular dorsal pancreatic duct, which is entire length, as we are seeing here, it has a proximal part and the distal part. The proximal part of the dorsal pancreatic duct, this is which is present on the back side, they contribute to this particular accessory pancreatic duct. So this front one, or this particular anterior half of this dorsal pancreatic duct, contributes to form this accessory pancreatic duct. From this part is going to this one. The distal part of the dorsal pancreatic duct plus this entire length of the ventral pancreatic duct fuses together and makes this particular main pancreatic duct, which opens with this particular common bile duct to form into this main pancreatic duct together as the ampulla of Vater, which is lying on the major duodenal papilla, second part of the duodenum. So this compared to the rest of this particular organ formations or these gland formation. So it was two to start with, ventral and dorsal. Ventral one is small, dorsal one is large. The ventral one eventually has to shift the place because of the rotations of the stomach, moves backside, eventually joins with this particular backside pancreatic bud, which is known as the dorsal pancreatic duct. So this particular ventral one fuses together with this particular dorsal pancreatic bud, becomes the one or single pancreatic bud. Now this particular union contributes separately to this particular formation of the pancreas. This particular ventral one contributes a small portions of the adult pancreas formation. The pancreas, if you look at this head of the pancreas with the uncinate process, which is lying at the bottom part, so lower part of the head with this uncinate process is only contributed by this particular ventral one. This is what you're seeing here, the anterior segment, and rest the posterior segment is building or forming this. Now each of this particular bud has a duct pierced by it. The ducts also unites with or exchange with each other. The entire thing of this thing, which is known as accessory pancreatic duct and main pancreatic duct. So the main pancreatic duct is partly contributed from this particular ventral or entirely by this particular ventral pancreatic duct with this particular distal end of the dorsal pancreatic duct, and this proximal end of this dorsal pancreatic duct is contributing to this accessory pancreatic thing. So this pancreas thing, we have to talk about which part of this particular pancreas is coming from what, this picture, and this duct system, which duct is coming from what part. So this two contributes of this particular pancreas is very important to understand and write it out. We have this particular pancreas to talk about. We have to talk about this particular pancreas development. We have to talk about this particular different parts of the pancreas development. So is this particular duct system of the pancreas. Now, list thing is over there, and next move to this particular clinical anomaly which is related to this gallbladder and pancreas. So, let's start with this particular more important versions of the pancreas, and then we move to this particular gallbladder because that's more extensive. So, we learned this particular pancreas developed from the pancreatic bud, and we have seen this ventral and dorsal pancreatic buds. So, sometimes by anomaly, by mistake, instead of the single pancreatic ventral bud, we have two ventral pancreatic bud. We call them as bifid ventral pancreatic bud. So, we have seen this particular ventral one, small one, single, but in some anomalous condition, instead of the one, we may have two ventral pancreatic bud. Now, as a result of this rotation, when this particular rotation taking place, this particular thing which is two ventral pancreatic bud also moves posteriorly. Now, here is the catch, is this particular ventral bifid pancreatic bud, as it is rotating, switches around this particular developing gut tube. So, this particular gut tube is the duodenum region where this particular pancreatic duct is opening. So, this particular bifid ventral pancreatic duct swings around and encircles around this particular growing second part of the duodenum and encase like this, and hold this particular pancreas like both hands as you are grabbing this thing. So, this particular anomalous pancreas, because of this particular two bifid ventral pancreatic bud is formed, grows around this particular second part of the duodenum, grows into this particular second part of the duodenum, and this particular pancreas, we call them as annular pancreas. Now, this annular pancreas is an exam important region. So, this particular growth or development of the annular pancreas is important. How this particular annular pancreas is formed, this particular simple word explains it, is the bifid ventral pancreatic bud, and this particular rotation with this one is swinging anteriorly, other is swinging posteriorly, encircling like this the second part of the duodenum, holding it and grabbing together. So, this formations of the ventral and dorsal bifid pancreas around this particular second part of the duodenum, which is leading to a disease, we call them as annular pancreas. And this particular annular pancreas, if it is there, you can see that it is choking the second part of the duodenum. As it is choking the second part of the duodenum, the food material cannot pass through. That leads to the obstruction. We call this as intestinal obstructions. So, this particular intestinal obstruction comes with this particular food material regurgitating back or vomiting out. So, this particular person who has this particular disease is presenting with the regurgitations of the food material, just like we have seen that hypertrophic pyroluic stenosis, where the pyrolus is thickened. Now, the difference with that particular clinical presentation with this one is that in case of this pyroluic hypertrophy, we have seen the vomiting is non-bilious. Here, this particular bile duct opening is there. So, this particular food material comes over here, along with this food material is going out, along with this biles also coming out. So, that leads to this particular vomitus, which takes this green stain. We call them as bilious vomiting. So, the color of the vomitus actually helps us to determine where the obstruction is. If it is before the second part of the duodenum, or if it is after the second part of the duodenum, the opening of the ampulla of Vater, which is bypassed or not. So, this particular clinical clue which help you to understand this particular cases about this. So, this particular annular pancreas is one of the clinical problem regard to the anomaly we have to understand. Moving to other clinical problems related to it, we have this particular gallbladder problems. There are lots of gallbladder anomalies are there, and this is quite frequent. That's why this particular anomalies of the gallbladder, you have to understand, you have to prepare it really well. Now, the anomalies of the gallbladder may be of two different types. One is the gallbladder itself may be anomalous. That means the gallbladder may be one, maybe two, maybe absent. So, we call them as this particular cystic bud problem. Second anomalous problem with the gallbladder, which is even more common with the duct system of the gallbladder. That means the cystic duct or this particular hepatic duct may be anomalous. That connection point is anomalous. Based on that, we have two different sets of the gallbladder problem. So, if you understand this basic problem, it is easy to just like write it down. So, let's take it like this. Intrahepatic gallbladder. So that particular gallbladder is seen to be present in the hepatic fossa or gallbladder fossa in the liver region. So if this particular gallbladder is incorporated within this particular liver tissue itself, the gallbladder will be covered by the liver tissue. That particular gallbladder, we call them as intrahepatic. If it is floating outside or forming outside the gallbladder fossa, we call them as floating gallbladder. So that particular element will be there based on that. Other problem with this particular gallbladder is that we may have a single gallbladder, which is normal thing. So this particular cystic bud may be single. If it is single gallbladder, it is to be produced. In case of this particular cystic bud, if it is 2, we may have 2 gallbladders. So this particular gallbladder, if it is more than 1, we may have 2 gallbladders which is present. So we may have 2 gallbladders if it is present as a 2 cystic bud. If you have absence of the cystic duct or this particular cystic bud, we may have absence of the gallbladder, or maybe just like a gallbladder may be present inside or floating outside this particular anomalies. Maybe this particular gallbladder may have a cyst which is known as colorectal cyst, which is a cancerous cyst, which may be present in inborn or newborn kids that need to be immediately resected out. That could be this particular gallbladder anomalies related to this particular cystic bud formation. If you have this particular duct system abnormality, that means this particular duct may be faultily formed. So this particular connection point may be partly formed, partly not. So we call them as atresia of the bile duct. That means it's partly formed, partly not, replaced by the fibrous tissue. So it may be completely absorbed. Then no duct system is present. The complete atresia of this particular duct may be partially present or maybe may not be partially present. So this particular connection point, if it is partly formed, that leads to this particular atresia or different types of duct abnormality and as well as different forms of the gallbladder abnormalities. So the anomalies of the gallbladder, you must prepare well regard to this particular different types of this particular gallbladder problem. So this particular gallbladder problem, largely we see that they give the questions based on this particular anomalies of the gallbladder and the cystic duct system abnormalities. So these are the 2 entities that you must prepare well regard to this particular pancreas, pancreatic error of the development, and gallbladder error development. Now, the last part of this upper GI system formation, which is leading to this particular midgut, is the duodenum. Now, as I have mentioned, this particular duodenum is lying on the junction point. So duodenum has got 2 parts. We call them as upper part of the duodenum and the lower part of the duodenum. So this particular duodenum can be divided into this particular embryologically in 2 phases. In case of this particular gross anatomy, we divide the duodenum in 4 segments: part 1, part 2, part 3, and part 4. In embryology, we make it simple like part 1 and part 2. So this particular difference of this particular development of the duodenum happens to take place into 2 regions. Based on this, the opening of this hepatopancreatic duct, that means where this ampulla of Vater is there, above and below, that's the point we divide. So we divide this duodenum based on this, how it is opening on. This particular opening of the pancreatic duct and this common bile duct, which pierces the second part of the duodenum. So above that particular opening, we call this as a first part of the duodenum, and the below that we call them as the lower or second part of the duodenum, embryological. So this particular duodenum, which is above this hepatopancreatic duct, is developed from this particular foregut derivative, and below this particular hepatopancreatic duct, we call them as midgut derivative. So this particular midgut is lower duodenum is coming from it, and this particular foregut is the upper part of the duodenum. Now, out of this, what's the big catch about learning about the duodenum? So it's in simple words, it is very easy to comprehend and very easy to write down about the duodenum development, because it has 2 parts only: above, which is getting from this foregut, and below it is coming from the midgut. But that's the problem, what happens with this particular duodenum. Now, as you can see, this particular upper part has got different blood supply and lower part is different blood supply, because embryologically this particular 2 sources are coming from 2 different components. So the blood supply of the foregut of this intestinal system is coming from the cystic artery, and this midgut is coming from the superior mesenteric artery. Now, here lies the problem. So, these blood vessels, when it is serving to produce a common organ, that's the trouble point. So, they always think of, he will be delivering, that's not my domain, and this one is, again, he's saying, oh, this is your domain. This is, has to be supplied by you. So, that particular lack of communication always happens. Similar to it, some other organs also have this particular problem, but in case of the duodenum, it is quite extensive. So, this particular communication between these branches of this cystic artery, celiac trunk, and this particular branches of the superior mesenteric artery has to be a very crystal clear in terms of supplying this particular duodenum, or else we have the trouble or the formation error of the duodenum, which is quite common in case of this duodenum. So, this small gut developmental error, which is common or very common. So, what kind of common gut or misformation can happen? We call them as intestinal atresia, partly formed, partly not formed, partly canalized, partly not canalized, because celiac trunk is thinking superior mesenteric artery will be giving it. Superior mesenteric artery is saying, I'm very tired, you give it. Something happens like this. And as a resulting, eventually leading to non-vascular region. If you have any area non-vascular, that is not growing. So, that particular thing having as atresia or fibrotic tissue leading to it. So, this region, which is because of this particular lack of vascular error, it may happen. Similar to this, if you have proper vascularization on this region, this particular tube initially was solid, later on was canalized or canal is formed. We call them as canalization of the tube. So, if we do not have a proper vascularization, the tube which need to be canalized is not also happening, leading to this particular absence of the canal. So, may have the atresia, that means partly formed, partly not formed, or may have lack of canal. So, that means we have this particular canal present in the first part of the duodenum, second part is lacking in here, resulting in the food material is not communicating to this particular intestine coils. Everything is fine except this particular narrow strip region. That's why this particular gut atresia, which is very common in case of the small intestine. These are the MCQ region that is commonly been asked. Why it is been asked? Because the clinical problem we encounter because of the gut atresia of the small intestine way large. So, we have the gut, we have called this large gut, we have this gut, we call them a small gut. Now, in case of the small gut, we divide it in the duodenum, then we have the ileum, then we have the jejunum likewise, or jejunum ileum. Out of these, all these, our large gut, we have this particular cecum, ascending, transverse, descending, sigmoid colon. Out of these regions, all of this particular element is not having this kind of episodes, which is known as vascular accident or atresia, which is very common in case of this small intestine involving this duodenum at the junction point of the first part of the second part. And this is how this particular pediatric surgeons have to work very high to canalize this or re-anastomose this. So, that's why we see that majority of this particular region, we have this particular atresia of this duodenum is quite very frequency is very high, and as a result of this, we see this MCQs or the exam questions are sticking to this particular gut developmental or this particular small gut development, specifically this particular specifically this particular duodenum development questions are coming. So, this is what we talk about this particular gut. Now, moving everything back. So, we learned about this particular glands, liver, we learned about this particular pancreas, gallbladder, and this particular gut over here. Let's think we are left with spleen. This involved the last year prof question. So, in the last prof question, the spleen development is given, which is out of blue. We do not see much of the spleen questions are coming. And I didn't mention about this particular spleen in this particular foregut derivative. So, you see that this particular tube of the gut, which is known as foregut, and derivatives of this, no spleen is there. So, this particular spleen is not a GI organ, but though it is present in the GI system. And this particular thing is picked up by this particular examiner. I don't know why, because this is not a embryo question which is of undergrad importance, but it is given. So let's talk about it. So this particular spleen tissue is not a GI organ or not a GI tissue. It is a mesodermal element which is coming. So this particular mesoderm, if you go to this particular development, endoderm, ectoderm, exoderm, that particular mesoderm or mesenchymal tissue contributes to it. So there are some kind of strip of this mesenchymal tissue which is stripping or stripped from these sources, moves to this particular dorsal mesogastrium in pieces. That means in bits they are coming. They are not coming together. Some tissues are coming, again some more tissues are coming, projecting and channeling over there. So this particular small bits of tissue traveling from this particular mesodermal region, traveling to the mesoderm region, settles down to the developmental septum transversum, which is going to be the future diaphragm, and settles down there. And once it settles down in peace, they coalesce and join together and form this particular splenic tissue. Now, if you see this particular spleen tissue in gross anatomy, you will see that it's have plenty of bumps in there. We call them as notches of the splenic tissues. So if you look at this particular spleen or splenic tissue, which looks like this, several notches are there because there are pieces of this particular mesodermal tissues are coming and joining. And as a result of these particular joining points, makes some kind of notches are there. So this particular spleen is formed from this mesodermal element, develops into this dorsal mesogastrium, that means behind the stomach, the mesogastrium, that means this particular peritoneum fold which is there, it is lying there, and this particular spleen grows in there. This broad ligament which is present behind, we call them as greater omentum, is split into two parts, which is coming from this particular diaphragm to this particular stomach and this particular splenic tissue to the stomach. So this particular dorsal mesogastrium, which is lying in the back side, split into two parts by this growing tissue into gastrosplenic and linorenal ligament. So this particular splenic tissue is not a GI tissue, it is coming from the mesodermal tissues, coming from this particular mesoderm, developing into the dorsal mesogastrium, growing in peace, coalescing, meeting together, forms this particular tissue, and that is why this particular spleen tissue coming over here, and this particular tissue, as it is resting, we get this particular blood supply from the same same artery which is supplying the foregut, which is coming from the splenic artery, which is going to supply to it. So this particular splenic tissue, which is receiving blood supply from this particular branches from the celiac trunk, which is derivative of the foregut, but not a component of the GI tissue, which is a purely mesodermal element. And as you can see that it's a reticuloendothelial organ. That means it is producing blood, it is producing defense cells, but not producing any kind of hormones or any kind of element which helps in digestion or any terms of food processing is concerned. So this concludes us to this particular development. Prepare well for the next day, because next day before we begin, we might give some questions to answer. Later on, we can just like produce these particular regions of this particular GI system development. So next day you come prepared with this particular thing, whatever we have talked so far, and a quick small exam will be projected tomorrow, next day before we proceed. So far whatever we have covered, emphasize in this particular region, development of the stomach, formations of the curvature, rotations of it, development of the liver, hepatobiliary system with the anomalies, with the diagrams, and derivatives of the mesentery. All right, enjoy the weekend.